Well, hello, everybody. So today is April 21st, and today we're going to figure out the other trig functions. So I'm going to give you all 6 trig functions today, okay? All right, so what we know from yesterday, all right, that this is a point, and it has an x and a y coordinate, and it's moving around in a circle, and the rotation would be angle theta that we rotate. So this vertical leg is y, the horizontal leg to our right triangle, because there's a right triangle here, is x, and then this is the center of the circle, so this would have to be the radius of the circle, which is also the hypotenuse of our right triangle. So we know from Pythagorean theorem that x squared plus y squared is equal to r squared, so that's still always going to hold and be true, okay? And then we also know from yesterday that the sine of angle theta is equal to the opposite, which is now always going to be y, over your hypotenuse, which is r, okay? So y over r, okay? And then cosine of angle theta is the adjacent over the hypotenuse. So that would be, in this case, it's always going to be your x now. Your x will always be the adjacent leg now, okay? And your hypotenuse is r, so that'd be x over r. And then tan of angle theta is your opposite over your adjacent legs, and that would be, in this case, always going to be y over x. Okay, so that's the 3 trig functions we went over yesterday, okay? So there's going to be 3 new trig functions, and what they are the reciprocal of these, okay? So the reciprocal of sine is called cosecant, okay? And we abbreviate with CSC theta. So cosecant, we say cosecant, I'll spell it out in just a minute, cosecant theta, and that would be 1 over sine theta. Because when we put 1 over something, that's always the reciprocal of it, okay? All right, so what this means is, instead of being y over r, this is now going to be r over y. And so the way I do it is, okay, if I'm asking for cosecant, I figure out sine, what the sine is, all right, and then I just flip it, okay, because that's what we're going to do, okay. Now there's some stipulations here. This radius, you're always going to have a radius for these, okay. There was a problem with tan when x came out to be 0. There's going to be a problem with this one when y comes out to be 0, okay. So y cannot be 0, okay, because that will make it undefined. Okay, so whenever that happens, because sometimes this will, we'd have to write undefined for that. Okay, so I said I was going to spell this out for you. Okay, so cosecant is spelled C-O-S-E-C-A-N-T, cosecant. So cosecant of angle theta. All right, and then the reciprocal of cosine is called secant theta. Okay, and that would be 1 over cosine of angle theta. And so since cosine theta is x over r, this one would have to be r over x. And once again, this denominator here can't be 0, so x cannot be 0. And then this is spelled, secant is spelled S-E-C-A-N-T, okay? So S-E-C, that stands for secant, okay? And then we have the reciprocal of tangent, and that's called cotangent. So we just abbreviate with COT of angle theta. That's 1 over tan of angle theta, okay? And so since tan is y over x, the reciprocal of this one would have to be x over y. And then once again, y cannot be 0, okay? And this is spelled cotangent. Okay, and just COT is just the abbreviation for cotangent, okay? All right, so I want to show you something, okay? This is called a trig identity that we're going to use in a couple units from now, okay? But I want to introduce it right now, okay? So you're not going to have to worry about this right now, okay? But I still want to show it to you, okay? So we know, and this is going to be a really useful thing that we use in the future, okay? So we know that tan theta is y over x, okay? So we know this is true. Okay, now what I'm going to do is I'm going to multiply by a version of 1, okay? So if I multiply y over x by 1, that's going to still be y over x, right? But the version of 1 I'm going to use is unique, okay? It's going to be 1 over r over 1 over r. Now, what happens when you multiply these? Well, you're going to have y times 1 over r, right? So that's going to be y over r. Big fraction bar, right? The main fraction bar right there. And then I also need to multiply this denominator with this denominator, right? X times 1 over r. And that would be x over r, okay? And what do we know about y over r? Well, up here, y over r is simply sine theta. So that means this numerator becomes sine theta over, and this x over r, if you look, x over r, well, heck, that's just cosine theta. So we have cosine theta. Now, what does this mean? Okay, all these equals, like this is equal to this, which this is equal to this, which is equal to, right? That means that tan theta must equal sine theta over cosine theta, okay? And that's the importance of this. So when we see tan theta in the future, we're not really going to do this today, okay? But when we see tan theta in the future, we can swap it out and replace it whenever we see it with sine of theta over cosine of theta, and we can make that substitution. Okay, this is going to be this is used a lot in a lot of future math classes. Okay, so now we know tan theta is the same as sine theta over cosine theta. So that's it. Okay. All right, so let's go move down to the bottom, and we're going to do example number 1. And we're just going to do some examples now because I've taught you everything, right? It's just the definition of what cosecant is. And you'll hear me repeat it over and over and again. Okay, if you see cosecant theta, that's 1 over sine. Sine is y over r, so this one has to be r over y. And I'm going to go through all of that, okay, with each of these problems. Okay, so here we go. All right, let's go to example number 1. So what I want you to be able to do is on example is I want you to find the values of these. So we're going to use a calculator, okay? Now, one thing to keep in mind, this first one, example 1a, it's in degrees. Where's the degrees on this one? And that's because it's not in degrees. This one's actually in radians, okay? And this one is also in radians, okay? All right. Now I'm gonna do this 2 different ways. Okay, I'm gonna do it with the graphing calculator, and then I'm also gonna do it with Desmos. Okay. All right. So the first one, let's do this one. Okay. So cotangent of 165 degrees. On our graphing calculators, and most calculators, you only have sine, cosine, and tangent. Okay. So there's no cotangent feature on on most calculators. Okay. So what that means is we got to switch this, okay? So what do we know cotangent is? It's the reciprocal of tangent, okay? So cotangent of 165 degrees is equivalent to 1 over tan of 165 degrees, okay? And we're going to put this into our calculator, and we'll get an approximate answer, okay? I'm going to go through all of these, and I'm going to do them all on the calculator and on Desmos all at once, okay? All right, so then cosecant of -1. Now this is in radians, right? Okay, so cosecant, this one's the reciprocal of sine, okay? So this must be the same as 1 over sine of -1 radians, okay? And then we're gonna put that one in our calculator and we're gonna get an approximation, okay? And then secant of 11. Well, the reciprocal of secant the secant is the reciprocal of cosine. So this is 1 over cosine of 11 radians, okay? And we'll get an approximation for that, okay? So I'm gonna go to the calculator and I'm gonna put these in, all right? And then we'll do it on Desmos too. All right, so we're at our calculator and you look at the top and it's all the settings, right? And you look right here and we're in radians, okay? All right, so there's a couple ways, that, and our first angle was, or the first trig function that we want to find the value of is 1 over tangent of 165 degrees. So if we type in 165, the calculator thinks it's in radians right now, okay? So there's a couple ways we can do this, okay? So we're going to type alpha x for the fraction, right? And we're going to type in 1 over, okay? And I'm going to type in tan, and I'm going to type in 165. Okay? And if we're in radian mode, you can override this, but you have to tell it that this is degrees. So there was a way to do that, right? We can go second and then angle, and there's our degree symbol, number 1. Remember that from when we did degrees, minutes, seconds? Okay? And then you could put this in, okay, and we get negative 3.732, okay? So another way you can do this is to go to the mode feature and switch your angle mode to degrees. This is how we normally do it in Honors Math 3, okay? And press enter and we highlight degrees. Okay, so now the calculator thinks you're in degree, it knows you're in degree mode, right? So now when we type in the 165, we don't have to put the degrees because automatically it's in degrees, okay? So we can do the same thing, and then we type 1 over tan, and we don't have to put the degree symbol now because automatically, because it's in degree mode, the calculator knows. And see, we get the same answer, right? So negative 3.732, okay? All right, so if you're in radian mode, you got to put the degree symbol. If you're in degree mode, you don't have to put the degree symbol, okay? All right? Okay. Let's go on to the next one, okay? So cosecant of negative 1. Okay, so I need to be back in radian mode, okay? So there's no way to override degree mode and make it radian, okay? So we need to go back and put it in radian mode. I would rather you keep it in radian mode, okay? Because that's how most of the things are done in future math classes, okay? So we're going to type second x for the fraction bar, and then 1 over sine of negative 1. And that gives us a value of negative 1.188, okay, because we're going to round to 3 decimal places. Okay, and then we want to do secant of 11, which is 1 over cosine of 11. So fraction bar, and then 1 over cosine of 11. And we get 225.953. So big number, right? Okay. All right, so let's go ahead and record these on our paper, and then I'm going to show you how to do this in Desmos, okay? All right. So from our graphing calculator, we got negative 3.732 and negative 1.188. And for secant of 11, we got 225.953. Okay, so I'm going to show you how to do these 3 problems using Desmos, because I know not everybody has a graphing calculator, okay? All right, now I'm going to tell you, in Desmos, they have the cotangent feature and the cosecant feature and the secant feature, okay? I don't want you to use it though, okay? Because you need to know these relationships, that cotangent is 1 over tangent, okay? That's circumventing what I want you to learn on top of what you're doing right now, okay? So please, there's no way I'm going to tell, all right? But I want you to do the reciprocal functions, okay? I want you to learn them in terms of sine, cosine, and tangent. It's going to be helpful for later on, okay? All right, just trust me, okay? You're going to struggle with memorizing it. If you don't start memorizing it now, you're going to have way more to memorize later on, okay? So just realize cotangent is 1 over tan, cosecant is 1 over sine, secant is 1 over cosine, okay, of the angle. All right, so let me show you how to do this on Desmos. All right, in Desmos, what you want to do is you want to go down here to the, well, actually first, you want to come up here to the wrench, and we want to be switched into degrees. So we want to be in degree mode, okay? All right, and we can click on the screen, and then come over here to the keypad, and then we want to select functions. Okay, so here we have sine, cosine, tangent, cosecant, secant, and cosecant. Please, 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 don't use these 3, okay? Let's learn the reciprocals, okay? All right, I'm not doing that just to be mean. I just know we need to be able to do this, okay? All right, so we're going to type in 1 and then divided by, and then it's going to be the functions, and then tangent, and we're going to type in 165. Now the calculator knows, okay, automatically, because we switched it into degree mode, okay, that 165 is in degrees, okay? All right. So just to show you, okay, if we did use those other features, okay, so cotangent, right? Cotangent of 165. Okay, you see how we get the same answer, okay? But please don't use this. Do it this way, okay? All right. All right. Now, the other two are going to be in radians, right? So we need to go back to the wrench for the graph settings, and we need to switch to radians, okay? All right, so we're back here, and we're going to type in 1 divided by, and this time we're going to select sine because we're doing cosecant, okay? So cosecant of -1, which is 1 over sine of -1, okay? And then close the parenthesis, okay? And then we get the same value we did with the graphing calculator, okay? And then we'll do secant of 11, which is 1 over cosine of 11. So 1 divided by, and then functions, and then cosine of 11. And you're going to see we get the same answer, okay? So we get the same answer. So this is how you use Desmos. So I do expect everybody to do this, okay? Because you have the availability Desmos or a graphing calculator, okay? All right, so I just wanted to show you how to access the trig functions in Desmos. Okay, all right, so that will be it for that. For example 2, use the given point on the terminal side of the angle theta to find the value of all 6 trig functions, okay? All right, so we know that our initial side is right here on the positive x-axis. We've rotated around an angle theta into the 4th quadrant, or the lower right quadrant. This is called the 4th quadrant, okay? And this point right here has coordinates 4, comma, -2 square roots of 5. So that means I would move right and down, correct? Okay, so I'm going to draw in my right triangle. Okay, and I know that this length, this horizontal leg right here, which is my x, is +4, and my vertical leg is -2 square roots of 5. Okay, so I need to get this r right here. Okay, so I can use Pythagorean theorem to get that, because I need all 3 sides, right, of this right triangle to do the trig functions, okay? So I know that 4 squared, and I would use parentheses around this case, so 4 squared plus -2 square roots of 5 squared must equal r squared, okay? So 4 squared is 16 plus, okay, now you're going to square the -2 and the square root of 5. So this looks like this. So -2 squared times the square root of 5 squared is equal to r squared. So this would be 16 plus, and this would be 4, and this would be 5, right? So 4 times 5. I'm breaking this down more than I usually do because I can't see you guys, okay? So this would be 4 times 5, which is 20. So we'd have 16 plus 20 is equal to r squared. You definitely can skip some of these steps, okay? And then 16 plus 20 is 36. So 36 is equal to r squared, okay? Now, if r squared is 36, r has to be a positive value. So the only value that that's going to work on is to square root both sides, and that would be r would have to be +6, okay? Because r is a length, so it has to be positive, okay? Our x and y are coordinates, so they could be positive and negative, but our r, okay, will always be positive for these problems, okay? So now we know we know we know x, we know y, and we also know r, okay? So we can find our trig functions, okay? So I'm going to come back up here. And so I know sine of this angle of rotation, which we're calling theta, has to be ry over our r, right? So -2 square roots of 5 over our r, which would be 6. So -2 square roots of 5 over r, which is 6, okay? Now, this simplifies because 6 is really 2 times 3, okay? So this becomes negative square root of 5 over 3, and I'd want you to simplify it, okay? Cosine of angle theta is x over r. So our x is 4 and our r is 6. So cosine of theta is 4, 6. But there's a better answer, right? Because both those are multiples of 2. Okay, so this becomes 2 over 3. Okay, and then tan theta. Okay, so tan theta is y over x. So that'd be negative 2 square root of 5 over 4. Okay, 4 is a multiple of 2, so this becomes negative square root of 5 over 2. Now you could also put the negative in front of the fraction. That'd be fine too, okay? All right, now let's do the reciprocal ones, the ones we learned today, okay? So the reciprocal of sine is cosecant theta. So cosecant theta is equal to, and I would just use this one, okay? So negative square root of 5 over 3 becomes 3 over negative square root of 5, or negative 3 over the square root of 5. Okay, now it's not okay to leave our answer like this, right? Because we have a square root we have a radical in the denominator, okay? Square root in the denominator. So what we want to do is multiply by a version of 1. In this case, it'd be square root of 5 over the square root of 5. So a better answer is this, negative 3 square roots of 5 over, that'd be square root of 25, which is 5. And that's the correct answer, okay? Or this is a correct answer too. It's just this is a simplified version of this, okay? So we need to know that this is equivalent to this. These are the same. Negative 3 over the square root of 5. If you put this into your calculator, or if you put this one into your calculator, it will give you the same decimal approximation, okay? So secant theta. Secant theta is the reciprocal of cosine, right? Cosine was 2 over 3, so this one has to be 3 over 2. And we're done with that one, okay? And then cotangent of angle theta, okay? Cotangent theta is the reciprocal of tangent. So tangent was negative square root of 5 over 2. So this would be negative 2 over the square root of 5. Once again, we need to multiply by the square root of 5 over the square root of 5. If you can do this in your head, I'm happy, okay? I'd actually like you to start being able to do this in your head. So this would be equivalent to negative 2 square roots of 5 over the square root of 25, which is 5, okay? And that doesn't reduce anymore, okay? And there's your 6 trig functions, okay? Based on where that angle of rotation and the x and y coordinate, you can find the all 6 trig function values, okay? This is gonna be important, okay? Because I'm leading you into other stuff, because this is gonna be 3 units that we're gonna do before the end of the year on trigonometry, okay? And this is just the beginning of it, okay? But what's important here is that for these 6 trig functions, we put in an angle of rotation and we get out a ratio of either, y, x, or r, some ratio that a combination of 2 of those, right? So this is important. We put in an angle of rotation, we get out a ratio, because we're going to have inverse trig functions. And if the trig functions, we go angle to ratio, the inverse trig functions will go ratio to angle, okay? And so that's just kind of setting you up for the future, okay? All right, so let's go to example number 3. Okay, for example 3, okay, this is going to be a lot like what we did yesterday, okay? It's just going to be with all 6 trig functions instead of just the 3 sine, cosine, and tangent, okay? All right, so I want you to find the exact value of sine of negative 3 pi over 4, okay? So we got to do our angle of rotation, okay? So we're going to draw a diagram. We're going to put it all together. This is the most important thing, okay? If I want to rotate negative 3 pi over 4, okay, remember I start on the positive x-axis. I'm going to rotate clockwise because it's a negative angle, okay? And I know right over here, that would be, if I make a half rotation, that'd be negative 4 pi over 4, okay? But that would be too much because I only want to do negative 3 pi over 4, okay? And remember, this is negative 2 pi over 4 right here. So negative 3 pi over 4, it would have to be right in the middle here, right? Okay, so this is our angle of rotation. It's negative 3 pi over 4. Okay, and then I know I'm going to draw in my right triangle. Okay, so if this is negative 3 pi over 4, this rotation, this reference angle right here is going to be pi over 4, because I'd have to go pi over 4 to get to the negative 4 pi over 4. All right, so this angle of the triangle is pi over 4, okay, which makes this angle also pi over 4. So what we have is a 45, 45, 90 right triangle. The two legs are both 1, but in this case, because I'm going left, this also has a direction, so it's -1. And I'm also going down to get to this point right here, so that'd be -1. And then my radius or hypotenuse has to be the square root of 2, okay? So what is sine? Well, sine is the y, which is this one, over the r, which is this one, okay? So this would equal -1 over the square root of 2. Okay, so that's the exact answer, but it's not the best answer, okay? So what I'm going to do is I'm going to start doing this in my head, okay? I'm going to multiply by square root of 2 over the square root of 2. This is equivalent to negative square root of 2 over the square root of 4, which is 2. So I want you to rationalize the denominator, okay? All right, so that's the right answer, okay? All right, now let's do secant of 5 pi over 3, okay? In essence, to do this one, because secant is the reciprocal of cosine, I'm going to take cosine, I'm going to figure out cosine, and then all I'm going to do is flip it, okay? That's all I'm going to do for this one, okay? So 5 pi over 3, right? Now this is a positive angle, so I'm going to rotate counterclockwise from this positive x-axis, okay? So I know right here is 3 pi over 3, okay? So every half rotation is 3 pi over 3. So if I keep going to right here, this would be 6 pi over 3, okay? And so right in the middle here would be 4.5 pi over 3, if you want to think of it like that. And that helps you to locate it in the right quadrant, right? Because 5 pi over 3 would have to be in this quadrant, okay? So it's going to have to be in the fourth quadrant, okay? So this is my angle that I rotated, and it's 5 pi over 3. All right, and I'm going to draw in my right triangle. And because that angle is 5 pi over 3, I would need to go another 5 pi over 3 to get to 6 pi over 3. So that means my reference angle would have to be pi over 3, which means this angle down here would have to be pi over 6. And from yesterday, opposite pi over 6 is 1. And because we're going in the positive direction, we're going to the right. It is going to be positive 1. I'm going to even put positive right there, okay? You wouldn't have to. Opposite the pi over 3 is the square root of 3, but the direction is we're going down, right? So this would be negative square root of 3. And then the radius or hypotenuse is 2, okay? Now, cosine is your x over your r, right? So 1 over 2. So the reciprocal of that would be 2 over 1. So this is equal to 2 over 1 or 2, okay? So we would want to write it as that's 2, okay? So secant of 5 pi over 3 is 2. Okay, let's go to the next two examples. I'm going to slide it up. We're really just going to go through and do the same thing. This is the most important thing of this entire unit, is being able to find these six different trig functions, okay? 11 pi over 6 is the rotation that we want to do, okay? So I know this is 6 pi over 6, because that's pi. So every half rotation is 6 pi over 6. So that means over to here would be 12 pi over 6. Well, halfway between 6 pi over 6 and 12 pi over 6 would be 9 pi over 6. And 11 pi over 6, okay, that would have to put me in somewhere in between here, right? And that's what's important, is you get it into the right quadrant. Okay? All right, so the relative size does not matter, okay? So this is my angle of rotation. It's in the fourth quadrant. I know that's 11 pi over 6, okay? Now, from here to here is 1 pi over 6. So that means my reference angle right here is pi over 6. Okay, I'm going to draw my right triangle now. If this angle is pi over 6, this angle right here would have to be pi over 3. This is a 30, 60, 90 right triangle. So opposite pi over 6 is going to be 1, but because I'm going down, it's -1. Opposite pi over 3 is square root of 3. I'm from the origin, I'm going right, so that would have to be positive square root of 3. And my radius or hypotenuse would be 2. Okay, so tangent is y over x. So this would be negative 1 over the square root of 3. So this is equivalent to negative 1 over the square root of 3. Okay, now good answer is the right answer, but it's not the best answer. Okay, so the best answer is we got to rationalize the denominator. We need to simplify it. So I'm going to multiply the top and bottom by the square root of 3. That would result in negative square root of 3 over the square root of 9, which is 3. Okay, cosecant of 2 pi. Okay, so I'm going to draw my diagram. This is, okay, I'm going to tell you, this, I'm going to say it over and over. You're going to get sick of me saying this, okay? This is the most important thing, that you're able to find secant of these angles and cosine and tangent. It is the most important thing because we're going to do that all the time in calculus next year, okay? All the time. And you have to recall this, okay? And pretty soon you're going to get so good at this that you're not going to have to draw the diagram. You can just picture it mentally in your head. But to get there, to picture it mentally, we got to draw a lot of diagrams in the process, okay? Okay, so right here, this is angle 0 pi, right? It's the initial side. This would be pi. So back here we'd be at 2 pi, right? So our angle would be like going like something like this, right? That would be 2 pi. Now it landed on an axis, right? So right here, when this happens, right, we get to let the radius be whatever we want, but the simplest radius is just 1. Let it be 1. Okay, so if the radius was 1, okay, then the radius is 1, then I would have to go out. This length right here is the same as the radius. So what are the coordinates of this point? Well, I'd have to go to the right and not go up or down. So this would just be 1, 0. Now, if you picked a different radius, let's say 2, okay, the radius is 2, then that means this coordinate right here would have to be 2, 0, because this distance that we travel from the origin to this point has to be the same as the radius, right? So if you did that, you wouldn't be wrong. You get to pick whatever radius you want. I just think the simplest one is radius would be 1, okay? All right, so cosecant, all right? Cosecant, and we have to go to our definitions. Cosecant is the reciprocal of sine. Sine is y over r. Y over r. So the reciprocal of that would be 1 r over y, 1 over 0. So this is equal to 1 over 0. Now there's a problem here, right? You can't divide by 0. So that means this is equivalent to being undefined. And I want you to write that. Okay? You can abbreviate U and D if you want to. Okay? All right. So that's what happens when we land on an axis, okay? All right, so how about cosine of negative pi over 2? Okay, let me fix this a little bit. I'm going to slide it up a little bit. Okay, so cosine of negative pi over 2. So cosine of negative pi over 2, I'm going to draw my x and y axis, okay? I'm going to start on the initial side. I have a negative angle, so I'm going to rotate clockwise, okay? I know this is negative 2 pi over 2. So this would have to be negative pi over 2. And so I'm on an axis again, right? This is negative pi over 2, the rotation. Okay, so what are the coordinates of this point right here? Well, when it lands on one of these axes, right, we're going to let r be 1. That's the easiest, okay? So now, from the origin, this distance from here to here has to be the radius, right? But since I'm going down, the direction would be negative 1, right? So my x-coordinate would be 0, and my y-coordinate would be negative 1. So cosine is x over r. So my x is 0 and my r is 1. So this is equal to 0 over 1. And 0 over 1 is not undefined. That's actually the number 0. Okay. Now, what would happen if you picked a different radius, right? Because up in this one, I talked about what if the radius was 2. Okay, for this one, what if we picked the radius of 2? Okay, then this distance from here to here would be the same as the radius 2, but the location of it would be negative 2. So the coordinates would be 0, negative 2, okay? And the radius would be 2, okay? So when you come up here, it'd be 0 over 2, which would still be 0. So you'd wind up with the same final ratio, okay? All right, so I just want to point that out. I just think the simplest one, pick radius of B1, okay? All right, Cotangent of 4 pi over 3. So we're going to draw our diagram. All right, 4 pi over 3. And I do a lot of these because you gotta really understand this, okay? So 4 pi over 3, we're going to start on the positive x-axis. We're going to rotate counterclockwise because it's a positive angle. I know if I rotate to right here, because I'm counting by thirds, this is 3 pi over 3. Okay, and then so every half rotation would be 3 pi over 3. So another 3 pi over 3 would put me at 6 pi over 3 over here. Right here, this would be 9 pi over 3. Sorry, not 9 pi over 3, 4.5 pi over 3. Because that's right in the middle of 3 and 6, right? Is 4.5. Okay, so 4 pi over 3, okay, would put me in the third quadrant. That's this bottom left one, okay? So this angle of rotation is 4 pi over 3. Now, that's this reference angle right here is pi over 3, right? Because I'm at 3 pi over 3, I got to get to 4 pi over 3. I got to go one more pi over 3, okay? So I'm going to draw my triangle to the x-axis, okay? Again, never draw it horizontally, okay? You're always, from the rotation, you're going to draw up or down, okay? Depending on what quadrant. If it's up here, you're going to draw down. If you're down here, you're going to draw up to the x-axis, okay? So here's my right angle. This is pi over 3. This one's pi over 6. Okay, so this is a 30, 60, 90 right triangle. The side that's opposite pi over 6 is always 1. Okay, so this is 1, but I'm going left. So that would be -1. All right, opposite the pi over 3, this leg right here has to be the square root of 3. But I'm going down, so it's negative square root of 3. This is the radius or hypotenuse, that has to be 2, okay? So cotangent, okay, so I'm finding cotangent. I'm gonna, cotangent is the reciprocal of tangent. Tangent is y over x, right? So this would be negative square root of 3 over -1, but I'm gonna flip that. So this becomes -1 over negative square root of 3. Now, negatives make a positive, right? Negative divided by negative makes a positive. So this is 1 over the square root of 3. Perfectly good answer, but it's not the best answer because we have a square root in the denominator, okay? So we're going to multiply top and bottom by the square root of 3, and that would give you the square root of 3 over the square root of 9, which is 3. So cotangent of 4 pi over 3 is 1 over the square root of 3 or square root of 3 over 3. This is the final answer, though, okay? This is the answer I'm looking for. Okay? Hopefully this is making sense, okay? This is really the last lesson for the entire unit because the next 2 days is just, you're gonna be practicing this, okay? All right, so let's go to the next example, which is example 4. All right, for example number 4, I know that cotangent of angle theta is equal to -1 over 5. Now, I don't know which one has the negative. Is it the top or the bottom, okay? It's one or the other, all right? And we're gonna determine that in just a minute, okay? And we know that sine of theta, okay, is greater than 0. Okay, now what does that mean, sine theta is greater than 0? Sine theta must be positive because greater than 0 is positive, okay? All right, so sine of theta is y over r. Okay, so what we have to do is you have to have both these two pieces of information to figure out where to place your angle theta, right? Because I didn't give you angle theta here. All right, so we're gonna have to figure it out. Okay, let me grab my blue pen. Okay, so what we're gonna do is we're gonna draw a diagram. Okay, in this quadrant, in this first quadrant right here, we know that x is positive and we know y is positive, okay? In the second quadrant right here, we know x is negative and we know y is positive. In the third quadrant here, I know x is negative and I know y is negative, okay? In this fourth quadrant, I know x is positive and I know y is negative, okay? All right. Now, we know that sine theta is greater than 0, okay? That means this ratio of y over r has to be positive. R is always positive. So the only way for this to be positive is where y is positive, okay? So automatically, we cannot be using this third quadrant or this fourth quadrant, because that would give me a sine ratio that would be negative. So I'm going to cross these out. Okay, so I'm just going to put an X there, like we're not going to use those. Okay, so because of this statement right here, we've eliminated these two bottom quadrants, because sine theta would not be positive. The sine ratio y over r would not be positive down here. It would have to be negative. Okay, all right, so that now we know we've narrowed it down to one of these two. Okay, now I know cotangent is the reciprocal of tangent, right? And tan is y over x, right? So x and y, because this ratio is negative, I know my x and y have to be opposite signs, okay? So what happens is, I know by this piece of information, I can now eliminate this quadrant right here. So it can't be this one. Why? Because if we were in this quadrant and we were doing the ratio, we would have to have a positive ratio, and we don't have that. We have a negative ratio right here, okay? So we've narrowed it down to it has to be the second quadrant. So it has to be drawn in this quadrant, must be, okay? That's the only place where this can happen, okay? All right, so I'm going to draw my angle of rotation. I now know that angle theta, I don't know the exact angle, but I know, okay, it has to be in this quadrant, okay? All right, and I know cotangent, okay, so tangent is y over x, so cotangent has to be x over y, okay? So that means that one has to be my x, okay? Now that's the one that's gonna be negative because I have to go left and up to get to this point right here. So this right here would have to be -1, okay? And my y would have to be +5. All right. So now now my job is I got to figure out that r right there, right? That's the hypotenuse. Well, what can I use? I should put a little right angle in here. Okay, so what do I know? X squared plus y squared equals r squared, right? So -1 squared plus 5 squared is equal to r squared. So -1 squared. Okay, very important. And I've taken off points. In fact, they get 0 on this problem. If you do not put parentheses around the -1, you will not get the right number, okay? So you got to square the -1. There's a difference between this and this. That's only squaring 1. You need to square -1, right? Okay, so this is going to be 1 plus 5 squared is 25 is equal to r squared. So that'd be 26 is equal to r squared. I just think about all the stuff that can go wrong, okay? And I'm trying to prevent that from you guys doing that, all right? Okay, so that would mean r would have to equal the square root of 26. Okay. All right. So now, because we have x, we have y, and now we have r, right? We can find all 6 trig functions. Okay. Or actually just the other 5, right? Because we already have one of them. Okay. So let's talk. What is sine of angle theta? Even though we don't even know the angle, right? Okay. So sine of theta would be y over r. So that'd be 5 over the square root of 26. And then that's a good answer, but it's not the best answer because we have a radical in the denominator. So I'd want to multiply top and bottom by the square root of 26. So that would give me 5 square roots of 26 over 26. Okay. And that'd be the correct answer. Okay. And then we want to do cosine of angle theta. Cosine of angle theta is x over r. So that'd be -1 over the square root of 26. That's not the best answer. So the correct answer would be negative square root of 26 over 26. Tangent of theta, okay? Well, actually, we just have to do the reciprocal of cotangent, right? So cotangent was -1/5, right? So tangent is -5 over 1 or -5, okay? Now, you could also do it over here, 5 over -1, right? Which would be -5, okay? And then secant, right? or let's do cosecant. Actually, you know what? I'm going to do cosecant right next to the side of sine because that's the reciprocal of it, right? So cosecant of angle theta. Okay, so which one's going to be better to do the reciprocal of? Which one's going to be best? It's going to be this one, right? Because what happens when I flip this? The square root's going to be on the bottom. What happens if I flip this one? The square root's not going to be in the denominator, right? So when I flip this one, the square root's going to be on top. So that would be the square root of 26 over 5. Okay? So, flip the one that saves you time and work, okay? And it'd be this one. All right? And the reciprocal of cosine is secant. So secant of angle theta. All right? And which one would be better to flip? Well, it'd be this one, right? So this is just going to be negative square root of 26 over 1, which would be just negative square root of 26, okay? And what we did is we found the other 5 trig functions, okay? All right? These problems I'm going to tell you, okay, because it deals with inequalities and we have a tough time reading inequalities. Usually these are the toughest problems for most of my students in the past, okay? They forget and they try to write square negative 1 this way, okay? That's wrong. You got to use, because this is actually negative 1, whereas you square this one, it gives you positive 1. See, it's different, okay? So that's important, okay? All right, so let's do this. Let's go to example 5 and we'll do that one. Okay, so example 5 is kind of similar to example 4 in that I gave you a trig ratio, tan theta, right? And I know that this is y over x, okay? So, all right, and I know that ratio is negative 2/3, okay? But here, instead of telling you something about another trig function, all right, what I'm telling you here is that this angle theta is between 3 pi over 2 and 2 pi. All right, so what does that tell you? Okay, so that tells you when I draw this, okay, this is 0, and I'm going to count by pi over 2. So this would be 0 pi over 2. This would be 2 pi over 2, okay? So every one of these is 2 pi over 2. So then this would be 4 pi over 2. But what is really 4 pi over 2? It's 2 pi, right? And so if this is 2 pi over 2 and this is 4 pi over 2, right here would have to be 3 pi over 2. And so I'm saying that theta is between 3 pi over 2 and 2 pi. So that means it has to be in this fourth quadrant, this bottom right quadrant, okay? So I'm just going to draw my terminal side here, okay? So this has to be my angle theta. And what's important is that you're putting these in the right quadrant because that determines the signs of everything, okay? That's why it's important to get it in the right quadrant, okay? So right here, I know I'm going to draw to my x-axis, okay? I can't get my reference angle, okay? Because I don't know what theta is, okay, exactly. But I know this is my y and this is my x. My x has to be positive, okay? So this 3 right here has to be the one that's positive because that's my x. So that's positive 3, and you wouldn't have to be positive 3. You could just write 3. And my y is negative 2, so that would be this one right here, right? This leg, and this is a right angle, okay? So once again, I got to find this radius, right? So I know that 3 squared plus, once again, I'm going to need to use parentheses, negative 2 squared is equal to r squared. Okay, so 3 squared is 9 plus negative 2 squared is 4 is equal to r squared. So that'd be 13 is equal to r squared, which means r is equal to the square root of 13. Okay, so now we know x, we know y, right? And x is 3 and y is negative 2. We know x, y, and r, so we can find all the trig functions, right? And we only need to find 5 of them because we already know one of them, right? Because tan theta was negative 2 over 3. Okay, so what is sine of angle theta? Sine of angle theta is y over r, so that'd be negative 2 over the square root of 13. A better way of writing that is negative 2 square roots of 13 over 13. Cosine of angle theta. Cosine of angle theta is x over r. So that would be 3 over the square root of 13. A better answer is 3 square roots of 13 over 13. Tan theta we already had, right? So then I'm going to go ahead and do cotangent of angle theta. Tan is y over x, so this one's going to be x over y. So that'd be 3 over negative 2. And see how it's the reciprocal of the tangent, okay? All right, now next to the sine theta, I'm going to do cosecant theta. Okay, so cosecant theta, which one's better to take the reciprocal of, right? It'd be this one, right? So this cosecant theta is equal to negative square root of 13 over 2. Done with that one. The reciprocal of cosine theta is secant theta. Which one's better to take the reciprocal of? It's this one, because when I flip this one, the square root's going to be on top. So this would be the square root of 13 over 3. And that's secant theta, okay? All right, so there's your other 5 trig function values, okay? All right, for angle theta. All right, guys, that's it for today, okay? So I'm going to put up the assignment sheet and let you know what the assignment is, okay? Okay, guys, so here's the assignment sheet, okay? And we talked about the 6 trig functions, okay? And what I want you to do is for today, okay? So today's the 21st. I want you to do worksheet TF6, okay? Now, there's not going to be any more videos, okay? So I'm just going to go ahead and write the rest of the assignments here, okay? Because you're not going to see a video anymore, okay? You're just going to have these assignments to practice this on. Some of these, there's some review problems from previous units, okay? Just do your best, okay? And if you need help, I mean, just refer back to the solutions and to help you get started if you get stuck, okay? All right. So worksheet TF7, I'm going to want you to do tomorrow, Wednesday. Well, you don't have to do it tomorrow. That's when I'm assigning, okay? I give you guys 48 hours to do all these, okay? And then TF8 is going to be the 23rd. And this is Tuesday, Wednesday, Thursday. And then worksheet TF review will be the 24th, okay? So there's not going to be any more videos the rest of the week. It's just going to be worksheets practicing this, okay? All right. If you guys need any help at all with this, you're struggling with one particular thing, please reach out. Just send me a message on Remind, post a message on Google Classroom, any of those things. And we can set up a time where I can just go one-on-one with you with a Zoom session and just help you out. Okay. And you can ask all your questions. Okay. All right. Okay. So let's do these the rest of the week. Okay. And I don't think this this one will be due Thursday. This one will be due Friday. TF7 will be due Friday. Okay. And then this one, TF8, will be due Monday. I'm not going to make anything due during the weekend. Okay. So this will be due Monday. And then this one will be due on Tuesday. Okay. All right. So you got plenty of time to do this. I mean, we're a week out. Okay. All right. If you're just really bored, you can get ahead. All right. Okay. All right. So you guys have a great day. I really miss you guys. All right. I miss your smiling faces. Okay. You guys just take care. All right. Bye-bye.